And the term involving dy was replaced by 0 on both sides because we knew actually that y is held constant. Now, the real difficulty in both cases comes from dx. And what we do about dx is we use the constraint. So here we use it by writing dg equals 0. Here we write the chain rule for g. That's the same thing, just divided by dz with y held constant. Okay? So this formula or that formula are the same, just dividing by dz with y held constant. And then in both cases, we used that to solve for dx. And then we plugged into the formula for df to express df dz, or partial f partial z, with y held constant. Okay, so the two methods are pretty much the same. Quick poll, who prefers this one? Who prefers that one? Okay, majority vote seems to be for differentials, but doesn't mean that it's better, okay? Both are fine. You can use whichever one you want. But you should give both a try. Okay, any questions? Yes? Sorry, can we use?
Like, our directional derivatives.
Yes, thank you. I forgot to mention it. Where did that go? I think I've erased that part. So, yes, we need to know directional derivatives. Okay, pretty much the only thing to remember about them is that df ds in the direction of some unit vector u is just the gradient f dot product with u. So that's, pretty much all we know about them. Any other topics that I forgot to list? No? Yes?
Can you erase free boards at a time?
Can I erase free boards at a time? No, I would need free hands to do that. Okay. Let's see. Okay. I think what we should do is look quickly at the practice tests. I mean, given the time, you will mostly have to think about it yourselves. But so hopefully you have a copy of the practice exam. Oh, yes. Okay, so let's look at the second. So the first problem is a simple problem. Find the gradient, find an approximation formula. Hopefully you know how to do that. The second problem is one about reading a contour plot. And so before I let you go for the weekend, I want to make sure that you actually know how to read a contour plot. So one thing I should first mention is, this problem asks you to estimate partial derivatives by reading a contour plot. We haven't done that, so that won't be actually on the test. We'll be doing qualitative questions like what is the sign of a partial derivative? Is it 0, less than 0, more than 0? You don't need to bring a ruler to estimate partial derivatives in the way that this problem asks you to. Okay, I guess. So let's look at problem 2b. So problem 2b is asking you to find a point at which h equals 2200, partial h, partial x equals 0, and partial h, partial y is less than 0. So let's try and see what is going on here. So a point where f equals 2200, well, that should be probably on the level curve that says 2200, so I can actually zoom in. And here's the level 2200. Okay? Now I want partial h, partial x to be 0. That means if I change x, keeping y constant, the value of h doesn't change. So which points on the level curve satisfy that property? Yeah, it's the top and the bottom, okay? If you're here, for example, and you move in the x direction, well, you see as you get to there from the left, the height first increases and then decreases. It goes for a maximum at that point. So at that point, the partial derivative is 0 with respect to x. And same here. Now, we're also told, and let's find partial h, partial y less than 0. So that means if we go north, we should go down. Well, which one is it, top or bottom? Top, yes. Here, if you go north, then you go from 2200 down to 2100. So this is where the point is. So now the problem here was also asking you to estimate partial h, partial y, and just if you're curious how you would do that, well, you would try to figure out how long it takes before you reach the next level curve. Okay, and you see that, so here, to go from here to here, so to go from Q to this new point, say Q prime, the change in Y, well, you'd have to read the scale, which was up down here, okay? That would be about something like 300. What's the change in height when you go from Q to Q prime? Well, you go down from 2200 to 2100. That's about, well, that's actually minus 100, exactly. Okay? And so delta H over delta Y is about minus 1/3. Well, minus 100 over 300, which is, whoops, I'm getting out of, minus 1/3. And that's the same, I mean, that's an approximation for the partial derivative. Okay? So that's how you would do it. Now, so, okay, let me go back to other things. So if you look at this practice exam, basically, there's a bit of everything, and it's kind of, fairly representative of what might happen on Tuesday. So, there will be a mix of easy problems and of harder problems. Expect something about, computing gradients, approximations, rates of change. Expect a problem about reading a contour plot. Expect one about, a min-max problem, something about Lagrange multipliers, something about the chain rule, and something about constrained partial derivatives. I mean, pretty much all the topics are going to be there.